Okay, so in the last video, I was talking about the estimates that you get from a simple linear regression model and a multiple linear regression model. And it seems like these estimates or these beta coefficients or these coefficient values, they are related. And we can represent a coefficient value of a simple linear regression model in terms of a multiple linear regression model using this relationship. For example, beta 1 coefficient that we will get from a simple linear regression model, it will be equal to beta 1 estimate from multiple linear regression model plus beta 2 and the correlation between x1 and x2. This was the relationship between x2 and x3. In this video, I'm going to show you an example in R that will prove this relationship. Okay, so here's the way that I'm going to go about this problem. The first thing I'm going to do is I'm going to regress x2 on our variable of interest x1. From this, I'm going to get delta 1 tilde. And then I'm going to regress our main dependent variable on x1 alone and get beta 1 tilde. And finally, I'm going to regress y on both x1 and x2 in a multiple linear regression and get beta 1 hat and beta 2 hat. And finally, I'm going to prove that beta 1 tilde will be equal to beta 1 hat plus beta 2 hat delta 1 tilde. Okay, so here's an example in R, and I'm going to use wage data. What we are interested in finding here is wages as a function of education and somebody's IQ. And the first thing I'm going to do is I'm going to regress x2 on education and get our delta parameter. So our delta parameter is about 3.53. The next thing I'm going to do, I'm going to regress our second equation, which is a single linear regression model, wages on our main variable of interest, which is education, and get beta 1 parameter for this one. Now this is beta 1 tilde. And finally, I'm going to regress wages on education and IQ in a multiple linear regression modeling framework and get both beta 1 and beta 2 parameters. So we have these values. So let's copy these values and bring these values in here. Okay, so our delta 1 value is, I'm not going to write everything. Let me write down only our coefficients of interest. So delta 1 is 3.53, right? And then beta 1 tilde is if we regress wages only on education in a single linear regression model, and this coefficient is 0.059. And finally, running a multiple linear regression model will give us beta 1 coefficient as 0.039 education plus 0.0058 IQ. Okay, so next we're going to prove that beta 1 tilde, this value 0.059 is actually equal to these coefficients. So beta 1 coefficient, it is here 0.039 plus beta 2 is 0.058 multiplied by this coefficient, which is 3.53, and our answer is 0.059. So it seems like we proved that these two values are actually equal. So no matter if you run a single linear regression model or a multiple linear regression model, there is a way of representing one in terms of other. So it all depends on the correlation between this x2 variable with this x1 variable and x2 variable with this y variable, which is represented by this beta 2 coefficient, and the correlation between x2 and x1 is represented using this delta 1. Essentially, if any of these is equal to 0, then no matter if we run a single linear regression model or a multiple linear regression model, we'll get the same parameters. All right, so next I'm going to ask you to go through these steps and work with an example and come up with the values. Okay, so here's an example. You have to use GPA1 data for this problem and follow these steps and then verify that this identity actually holds for this problem as well. All right, see you in the next video. Bye-bye.